here. Okay, so under dilation, the blank dimensions of the pre-image by the, okay, multiply, under dilation, multiply the dimensions of the pre-image by the scale factor to get the dimensions of the image. Right? We don't care about a dilation of a line. Right, so in general, a dilation changes the size of a figure unless the scale factor is what? Guesses? 1. Without changing its shape. Okay, we're not going to recall rigid motions because I didn't discuss those with you yet. We're not going to talk about what dilations preserve because I didn't discuss that with you yet. Okay, so now let's perform a dilation. So go down to this example. We want to draw the image of the figure below after a dilation with a scale factor of 3/2. What is 3/2 as a mixed number? 1.5, yeah. A dilation of 3/2 is basically multiplying by a scale factor of 1.5 or 1.5. Because the scale factor is greater than 1, are we making the image bigger or are we making it smaller? Adam? Bigger. We're going to make this bigger. So if you perform this dilation and all of a sudden your new image is smaller, you know you did something wrong, right? So it's going to be the same. How many sides is this? 1, 2, 3, 4, 5. All right, it's going to be the same pentagon. It's just going to be a bigger pentagon. How do we figure out how to make it bigger? What you're going to do is, see where it says pre-image and image? Your pre-image is your original figure. Your image is the new figure after the dilation. So we're going to list out the pre-image coordinates. We're going to list out the pre-image coordinates. So I'm going to start off and write out A, and then you start at the origin, and then we're walking 1, 2, 3. So it's 3 on the x-axis, and because we're not going up or down at all, it's a 0 on the y. So our coordinate is 3, 0. Now, points need to be written in parentheses. So if you just wrote 3, 0 and you don't have parentheses around it, every time there's a point and you don't put parentheses around it on the quiz, it's going to be -1, -1, -1, -1, -1. That is a lot of -1s. You don't want all of those -1s. Right? So every point must be written in parentheses. Right, can somebody tell me the coordinates for point B? Connor?
0, 2.
You got it. In our parentheses, 0, 2. What about the coordinates for C? Liv? You got it. -2, 0. Coordinates for D? James? Perfect. -2, -2. And the coordinates for E? Bridget? You got it. 1, -2. All right, so now to get the new dilated image, what you're going to do is you're going to take every coordinate and you're going to multiply the x coordinate by the scale factor and you're going to multiply the y coordinate by the scale factor. And the way we would write this is the scale factor is 3/2, so you'd write 3/2x and then 3/2y. And I'll show you how to do this. Okay, so my pre-image point is point A, which was the coordinates 3, 0. But now I need to dilate it. And when you dilate it, you call your new point A with a little slash on top of it. And we read that A prime. So that means this is the new improved A after the dilation, A prime. And that's just A with a little slash on top. And the way we figure out A prime is we're going to take our original A coordinates but multiply each one by the scale factor. So we're going to do 3/2 times the x coordinate, which is 3, and then we're going to do 3 halves times the y coordinate, which is 0. Now, generally speaking, when you're multiplying two fractions or a fraction and a whole number, you're allowed to cross cancel, cross simplify. But can I cross simplify 2 and 3? No. Since we can't cross simplify, all you're going to do is multiply across. Since you can't cross simplify, all you're going to do is multiply across. So when I multiply across, I get my a prime to be 3 times 3 is 9. 2 times 1 is 2, so we get 9 halves. And then what's 0 times anything? 0. Hey, generally speaking, in high school, we like to leave numbers as improper fractions. So we like to leave the 9 halves. But when it comes to graphing improper fractions is not the best. It's much easier to graph a decimal or a mixed number. So with that said, you all tell me 9 halves is the same as what? As a mixed number? 4 and a half. So I'm going to write 4.5, comma 0. All right, so now we're going to go back to our chart. And now we're going to write a prime. And we're going to write the new coordinates for a prime, which is 4.5, comma 0. Then we're going to plot that point. All right, so you start at the origin, and on the x-axis, you're going to go over 4 and a half. So 1, 2, 3, 4, and then half a box. And we're not going up or down at all since the y coordinate's 0. And then on top of it, I'm going to write a prime. Now we're going to do this for all of the other coordinates. So let's now go into b prime. So my coordinates for b are 0, 2. To go from b to b prime, what do I have to multiply by? Connor? 3 over 2. So this is going to be 3 over 2 times 0, comma, 3 over 2 times 2. Well, 0 times anything is 0. And then for the second part, over here, the 3 halves times 2, can I cross simplify this? Yeah, we can cross simplify. 2 goes into 2 how many times? 1 time. So we're left with 3 times 1, which is 3. So now my b prime is 0, 3. So we're going to go back to the chart. We're going to write b prime 0, 3. 1, 2, 3, put your dot, label it b prime. All right, I want you to do C, D, and E. I want you to do C, D, and E all by yourself. Are we ready? Okay, so someone tell me, what'd you get for C prime? What'd you get for C prime? Chase?
C prime -3, 0.
Anybody want to see me do this one? -3, 0 for C prime. We're okay? Okay, someone tell me, what'd you get for D prime? Erin? Perfect. Anybody need to see me get D prime? All right, what about E prime? What do we get for E prime? James? I got that too. Anybody need to see me get E prime? All right, so for E prime, we're going to take E, which is 1, -2, and then we're going to go to E prime. How are we going to go to E prime? We're going to multiply by the scale factor, which is 3/2 times 1, comma, 3/2 times -2. Are they talking to you guys?
Oh, Justin is so smart boy.
Okay, so now when you multiply 1 times anything, don't you just get what you multiplied it by? So for my E prime, I have 3/2. And then for the second one, remember, you're allowed to cross simplify. So 3 goes into -2, -1 times. And then you're left with 3 times -1, which is -3. So now for the purpose of graphing, it's a lot easier to graph a mixed number or decimal than it is an improper fraction. So we say, okay, well, 3/2 is the same as 1.5. 3 divided by 2 is 1.5, comma, -3. Hannah, are we good? Okay, so now let's plot these points. So C prime is -3, 0. So there's my C prime. D prime is -3, -3. There's my D prime. And E prime is 1.5. So you go over 1, and then half 1 over, and then down 3. 1, 2, 3. All right, so now once you've gotten all your new coordinates, don't forget to connect them to make your new image. Right. Should the shape look exactly the same as the first shape? Yeah, the shape should look exactly the same, just bigger or smaller. So if you started off with a pentagon and now you ended up with a triangle, you know you did something wrong, right? Or if you started off with a pentagon and then you ended up with some kind of star, you know you did something wrong. All right, ready to move on from dilations? All right. 8.1, ratios and proportions. A ratio is a comparison. Actually, let's use the word, let's say quotient. It is a comparison, but I want the word quotient. A ratio is a quotient of two numbers. And it's usually used to compare things, right? A ratio is usually used to compare things. So ratios can be written many different ways. When it says the ratio of 5 meters to 3 meters, ratio of 5 meters to 3 meters can be written the following ways. Right? I'm going to put a star on the first way because that's the way in class we're going to use it the most. We're mostly going to write ratios as fractions. And the order of the fraction does matter. Whatever comes first in the written words, that has to be the numerator. And whatever comes second in the written words has to be the denominator. So since it says 5 meters to 3 meters, the 5 has to go in the numerator and the 3 has to go in the denominator. 5 to 3. Okay. You guys are probably most used to seeing ratios written with a colon. Again, the order matters. Whatever comes first is written first. So this would be 5:3. You can use the word 2, so this would be 5, 2, 3. And the very last way to do this is with a little baby division sign, 5 division sign 3, which we will never use that. We'll never use that baby division sign. Okay, a proportion. A proportion is an equation stating that 2 or more ratios are equal. Now, there's ways to check that a proportion is true. Most of the time, you guys are just able to look and be like, yeah, I know that's true, similar to this first one. A half is equal to 5 over 10. How do we know 1 to 2 is the same as or equal to 5 to 10? Because 5 over 10 can reduce to a half, 1 over 2, right? So a lot of times you can just reduce a fraction and know that they're the same. Another way to check that a proportion is true is anytime you have 2 ratios equal to each other, you're allowed to cross multiply those 2 ratios. When I say cross multiply, do you guys remember those butterfly wings? Did this in middle school? Remember that? So you can multiply on a diagonal. So you would say, okay, well, 1 times 10, does that equal 2 times 5? Well, 1 times 10 is 10. 2 times 5 is 10. Does the left side equal the right side? Yes. So the proportion that was originally written is a true proportion. So you can make the fractions equal each other, or you could cross multiply to check that their products are equal. And that's how you can tell if the proportion is true or not. All right. So anytime you have a proportion, there's names for the different spots, right? So you have one fraction equals another fraction. The first numerator, which is represented by A here, that first numerator is going to be called the first term, the first term. The first denominator, which is written as B here, the first denominator, which is written as B, is called the second term. The second numerator is called the third term. And the second denominator, which is represented by D, is called the fourth term. Okay, now I'm going a little bit off topic here, but it will come back into play in a couple of problems. That's why I'm doing this. So when you have a proportion, do you all agree it's the first term over the second term equals the fourth term, oops, sorry, not the fourth, equals the third term over what? The fourth term. So then what happens when you cross multiply? What happens when you cross multiply? What ends up happening is every time you cross multiply, the first gets multiplied with which term? The first and the fourth get multiplied together. And then on the other side of the equal sign, what happens? The second and the third get multiplied together. Do we all agree? Okay, we'll keep that in our heads for later. Okay, now there's more names, more vocabulary coming into play. So anytime you have a proportion, the first and fourth term, so spot 1 and spot 4, they're called the extremes. And this will come into play when we do proofs. The second and third term, they are called the means. So 1 and 4, the extremes, 2 and 3, the means. And there's a theorem. We're not going to use this theorem until we get into proofs, but we will be doing proofs in this chapter. And the theorem is called the means extremes product theorem. Means extremes product theorem. And basically all the means extremes product theorem does is tell us we are allowed to cross multiply. We are allowed to cross multiply. That's essentially what the means extremes product theorem tells us. We are allowed to cross multiply a proportion. All right, are we ready to do some problems now? All right, so example 1. It says solve for x. Do we all agree that this is a proportion? Yeah, and what are you allowed to do with proportions? We are allowed to cross multiply. So when we cross multiply, I'm going to get 1 times the quantity of x plus 2 is equal to x times x. Well, 1 times anything is what? Itself. 1 times anything is itself. So this left side stays x plus 2. X times x, please do not tell me it's 2x. Adam?
X squared.
X squared. X times x is x squared. Because of this x squared, we're going to have to do a special kind of algebra. Okay, what kind of algebra are we going to have to perform to solve this? Chase. Factor. Excellent. Because it's x squared, we have to factor. But before we can factor, it needs to be set equal to 0. But the x squared can never be negative, so I can't subtract the x squared to make it 0, because then I'll have a negative x squared, and you can't factor if x squared is negative. So instead of moving the x squared, I'm going to keep the x squared where it is, and I'm going to subtract the x, and I'm going to subtract the 2 to make that side 0. Charlie, you with us? Okay, so I'm going to subtract the x, I'm going to subtract the 2. So this is going to give us 0 is equal to x squared minus x minus 2. So x squared minus x minus 2 equals 0. Now remember, there's really a 1 in front of this x. So when you come to factor it, refresher here, you need 2 numbers that multiply to the last number, including the sign, and the same 2 numbers have to add to the middle coefficient. Only Adam and Chase? Aaron.
I put x minus 2 and x plus 1.
Yeah, you got it. So our factors are negative 2 and positive 1. Negative 2 times a positive 1 is negative 2. Negative 2 plus a positive 1, do we agree that's a negative 1? Yeah. So now we make up our parentheses. The first thing in each parenthesis is x, then it's the numbers that we guessed. So it's a negative 2 and a positive 1. At this point, now we solve. We solve the equations by setting each parenthesis equal to 0. So we're going to have an x minus 2 is equal to 0 and x plus 1 is equal to 0. X will equal positive 2, that's one answer, and x will equal negative 1, that is another answer. You are absolutely allowed to have a negative x. What you're not allowed to have is a negative angle or a negative segment length. But do these x's represent an angle or segment length? No. So both answers are acceptable or necessary, to be honest. Both answers are necessary. Bridget.
But isn't x a denominator? Doesn't it have to be positive?
No, a denominator doesn't have to be positive. A denominator just can't be 0.
Right.
So if you're 0 in the denominator, then it's undefined, but any other number's okay. Or, well, you'll learn in Algebra 2, it also can't be, imaginary. or a radical. That's algebra 2. So as far as geometry is concerned, you just can't have 0 on the denominator. That's all. Okay. Example 2. Find the fourth term, sometimes called the fourth proportional. So fourth term, fourth proportional means the same thing. If the first 3 terms are 2, 3, and 4. So if you all remember, we talked about this. In a proportion, it's the first term over the second term equals the third term over the fourth term. So now we substitute in our numbers. So the first 3 terms are in this order. So it's going to be 2 over 3 equals 4. Do we know what the fourth term is? No. So what am I going to put there? X. Can we figure this out in our heads? Yeah, absolutely. Well, let's say it's going to be, let's say it was a little bit more difficult, all right? If it were a little bit more difficult and you can't figure it out in your heads, what should we do? Cross multiply. I've really missed you, Chase. All right, so now we're going to have 2x is equal, 2 times x is equal to 3 times 4. 2 times x is 2x, 3 times 4 is 12. What should we do? Divide by 2. X is equal to 6. All right, are these proportions equivalent? All right, the way you check to see, since these are all variables, the way you can see if these proportions are equivalent is to cross multiply and check to see if your products are the same. So if I'm cross multiplying this first one, we're going to get P times Q is equal to R times S. Do we agree? All right, now let's check the next one. Again, P times Q will equal S times R. But is multiplication commutative? Yeah, multiplication is commutative. What does that mean? Is R times S the same as S times R? Yeah, that's commutative. That's what it means. It doesn't matter. 3 times 5 is the same as 5 times 3. The order you multiply doesn't matter. So is R times S the same as S times R? Yes. So far, are these all equivalent? Yes. Let's check the last one. So here we're going to have R times S is equal to P times Q. Is that okay that we flipped it on different sides of the equal sign? Yeah, so are all these equivalent? Yes. All right. Can we keep going? Okay. If 10x equals 7y, find the ratio of x to y. I'm going to show you 2 different ways to do this. I do not care which method you choose. Okay. First method, a little bit longer. 10 times x equals 7 times y. Do you agree? 10x is the same as 10 times x, and 7y is the same as 7 times y. Right. So this has been something that's already been cross-multiplied, and now I want to put it back into a ratio. Because it's already been cross-multiplied, remember it's the first over the second equals the third over the fourth. When you cross-multiply, your first gets multiplied with your fourth, and your second gets multiplied with your third. Yes, do we agree? All right, so that's telling me that 10 is the first, which means x has to be the fourth. 7 is the second, which means y is the third. Now that I know this is the first, this is the fourth, this is the second, this is the third, can I put it back into a proportion? Yeah, so if we're going to put it back into a proportion, it's going to be 10 over what?
7.
Good. Equals what over what?
Y.
Y over x. Now be very careful. I asked for the ratio of x to y. What have we written the ratio of? y to x. Simple fix. What's the simple fix? Flip it. So if y to x is 10 to 7, what's x to y? 7 to 10. Can I show you the other way now? The other way is a little bit quicker, I think. Anybody still copying this? Okay, the second way. Okay, so we have 10x equals 7y. Do we all agree we need to get the ratio of x to y? So I need to get x in the numerator, y in the denominator, nothing else with it. This is the algebraic way of doing this. So I'm going to start off by getting x and y together on the same side. So I'm going to go here and I'm going to divide by y. So now we have 10x over y equals 7. Well, isn't that 10 being multiplied with the x?
Just divide it.
So I can just divide it, exactly. Because that 10's being multiplied with the x, I can just divide it on both sides. And when I divide it on the left side, won't it cancel? So now we're x over y equals 7 over 10. Did we get the same answer? Yes. How many people like the first way better? How many people like the second way better? Okay, thanks for voting, everybody. Thanks. I really appreciate it. All right, let's do one that's a little bit more difficult. So now I'm giving you a proportion, but this proportion's a little bit complicated because I have x and y's and a's and b's, and I'm asking you to find the ratio of just x to y. So in this scenario, what I need you to do is I want you to start off by cross multiplying and see where we go from there. So when we cross multiply, I'm going to get b times the quantity of x minus 2y. Make sure you use your parentheses. Equals y times the quantity of a minus 2b. What do you think I'm going to tell you to do now? Any ideas on what I'm going to tell you to do now? Connor?
Divide.
Not divide, no. We're going to still try to simplify things down. You want to try again? No? Olivia? Distribute. I'm going to distribute in this b. When I distribute in this b, we're going to have multiple variables, and that's okay. Generally speaking, it's not a must, but it's sort of just a rule of thumb in algebra. When there's multiple variables, you always just write it in the order it shows up in the alphabet. So here, when I multiply b times x, instead of writing xb, we would write bx because b comes first in the alphabet before x. And then minus 2by. And then on the other side, what should I do? Distribute in the y. So this becomes ay minus 2by. Anybody see anything that can really help us out here? Something we can do that will really help us out? Milo? Excellent. We can add 2by on both sides and they cancel, which is huge for us. So this cancels and this cancels. So now I'm going to have bx equals ay. I think the majority of people said they like the algebraic way, right? Is that what we said? All right, so if we like the algebraic way, what did I ask us to find? The ratio of x to y. So what do I need in the numerator? X. So I'm going to leave this x here, and what am I going to do? Divide by y. So I'm going to divide by y. So then I'm going to have bx over y equals a. I need to now get rid of the b. How do I get rid of the b? Divide by b. So now I have xy is equal to a over b. All right. Yes.
I was asking if you could grow up a little bit.
Oh, sure.
Thank you.
Is that good enough?
Yeah, I got it.
You got it? Okay. We good, Connor? Okay. So now another definition. A geometric mean, also known as a mean proportional. Right? A geometric mean or a mean proportional, they mean they're the same thing, is when you have a proportion and there's the same number in spot 2 and spot 3, the second term and the third term. So here, the geometric mean in letter A is 4 because it's the same number in spot 2 and spot 3. What is the geometric mean represented by in letter B? X. So it's the same number. We don't know what it is, but we know it's the same number because it's represented by the same variable. Now, we've heard that word mean before. Where have we heard that word mean or algebraic in mathematics? Where else have we heard in mathematics the word mean? Chase?
The average?
The average, exactly. Now, an arithmetic mean is very different than a geometric mean. So let's see the difference. When we're finding the arithmetic mean, you take the average. So you add the given numbers then divide the sum by the amount of numbers you have. So if I'm finding the arithmetic mean of 3 and 27, what am I going to do? 3 plus 27 and then divide it by 2. What's 30 divided by 2? 15. So the arithmetic mean is 15. All right, geometric mean. To find the geometric mean, what we're going to do is we are going to set up a proportion. Put an X in spots 2 and 3. And the given numbers in spots 1 and 4. Then cross multiply to solve. All right, we ready? So I'm going to set up a proportion. And what did I say? Put an X in the second term and the third term. And the numbers they gave us, what numbers did they give us? 3 and 27. Those go in the first and fourth term. It doesn't matter which one's the first and which one's the fourth. So I'll put 3 in my first and 27 in my fourth. And now what do I need us to do? Cross multiply. When we cross multiply, x times x is not 2x. What's x times x? X squared. 3 times 27 is 81. We are going to solve this. To undo a square, you are going to take the square root. To undo a square, you're going to take the square root. So you're asking yourself, what times itself gives me 81? 9 and what else?
9.
What kinds of 9?
1 9. The number. Wait.
Olivia? -9, right?
Oh.
-9 times -9 is also 81. So our answer becomes plus or minus 9. You need to account for the positive and negative. If you do not, you lose some points because you're missing a whole answer now. So anytime you take a square root, it's immediately plus or minus. Always, your answer is immediately plus or minus. You have the positive value and the negative value of that number. All right, we're not going to do these independents, but I am going to do number 3 with you. So 2 supplementary angles are in the ratio of 3 to 5. What does it mean if 2 angles are sup? Add up to 180 or a? No, supplementary 180 or a, not a triangle. Straight angle, you got it. So I'm making a straight angle. And now remember, I've been stressing this probably since September. The minute you take numbers out of a ratio, what must you put with it? An x. So I will say one angle is 3x, the other angle is 5x. What is the equation here to solve? Good. 5x plus 3x equals 180, which is 8x equals 180. We can solve this. X will equal, I don't know. What is it? 20 what? 22.5? Okay, thank you. 22.5. And then I want the larger angle. Which one's larger, 5x or 3x? 5x. So we're going to do 5x, which will be 5 times 22.5. Can somebody tell me what that is?
112.5.
Thank you. 112.5 degrees. All right. Your homework is as listed. We got 6, 8, 14, and 19. We are done.